Now we're going to be taking a look at equation conversion rather than just ordered pairs, and it's a little more complex than just doing an ordered pair, as you might imagine. Now, at the top of your paper, you probably want to write down these two important ideas: the fact that x is r cosine theta and that y is r sine theta. Those are incredibly important to us. We're going to use them every single time going from rectangular to polar. And our general strategy on a lot of these is to, anytime you see an x or a y, you're going to replace the x and or the y with one of these, and then you're going to solve for r. You know how with a rectangular we always solve for y, or a lot of times we do solve for y? Well, in a rectangular conversion into polar, that polar equation, you want to say it's r equals something. So those are the two basic steps that we're going to be taking here in the next two examples. So rectangular to polar, I've got an x and a y involved in here, so I'm right away going to take this and this. And in fact, we could do this a couple different ways, but I think right now I'm going to go ahead and evaluate this square on here. So if I squared this binomial, I would have x squared minus 4x plus 4, and then I'm just going to write out the rest, plus y squared equals 4. Now, every time I see an x, I'm going to put in my r cosine theta, and anytime I see a y, I put in r sine theta. So right here I have r cosine theta, messed up there. This is r cosine theta, and it's squared. The r value, or the x value, has to be squared. Minus 4 times, here's another x to replace, r cosine theta, plus 4, plus, now I've got y squared, so that's r sine theta, replace the y, and it is squared, and it equals 4. I'm going to clean this up a little bit here. See how I've got a plus 4 and a 4 over there. Subtract 4 off of both sides, and those are going to get out of our way. Now, looking here, I need to square each of these pieces. So this is actually r squared times cosine squared. And then I've got minus 4r cosine theta. And the same thing is happening here. This is r squared sine squared theta. Now notice I've got a couple r squareds going on here. I've got one here, and I've got one here. So I'm going to think about regrouping those two terms together and factoring out an r squared. So this would be r squared times cosine squared. And then I've got a plus, and if I take the r squared out of this term, all I would have left is the sine squared theta. And you should see something right there that you recognize. That's just one. So this is r squared minus 4r cosine theta. Now that's about as simple as I can get it right now, and I forgot that this should be equaling 0 all along. Don't be sloppy like me. Alright, now our other thing is we were supposed to be, after replacing, we're supposed to solve for r. Okay, let's go back and finish that. So let's solve for r. Okay. Now solving on this, I've got a squared term and a linear term, so I'm going to factor. So I factor out an r minus 4 cosine theta equals 0. So now I'm going to set each factor equal to 0. I have r equals 0, and I have r minus 4 cosine theta equals 0. Well, this one over here is kind of bogus. R equals 0, it's just a point. So that doesn't really do a whole lot for us. This over here is a little bit different. Solving for r here, I get r equals positive 4 cosine theta. And that is actually a circle. Now, we are not venturing into the actual polar graphs, but if you're the adventurous sort and you'd like to check that out on your calculator, put your calculator into radian, or not radian mode, well, you'll need it in radian mode, but into polar graphing. And when you pull up your y equals, instead it will say r equals. And if you type in for cosine theta, you will see a circle. Okay, so there's that example. That one turns into a circle. Okay, here's another one. And this was linear to begin with. You can see you got an x and a y, and they're both first degree. So this is going to be a line, whether we graph it rectangular or polar here. So this is 4 times, replace the x, so this is r cosine theta, plus 7 times, replace the y with r sine theta, minus 2 equals 0. So I'm going to clean this up a little bit. They both have an r. Factor out the r. So I have r times 4 cosine theta plus 7 sine theta. I'm going to go ahead and move the 2 over because I'm trying to solve for r. So that equals 2. And if I need to isolate this r, it's just being multiplied by this sum. So I'm simply going to divide both sides by that sum. And when I do that, I will have that r equals 2 divided by the sum 4 cosine theta plus 7 sine theta. And that is it. That is the conversion for that linear equation.